Hi, just a quick review of primes and composites. So factors are a number that you multiply in order to get a number, and prime numbers only have two factors, that's one and themselves. Composite numbers have more than the two factors. So 10, we know, is 1 times 10 or 2 times 5, so that would be a composite. 5 is only 1 times 5, so that would be a prime. 12 has more than two numbers. You can multiply 3 and 4 or 2 and 6. That's composite. 18 is also composite, but 41 is prime because the only numbers that multiply to get 41 are 1 and 41. So I just wanted to do a quick review of that. And let's jump into the lesson. This is page 55 of our book, and it's asking us to record information from the video. So let's take a moment to watch that video. So I took some notes during the video. I noticed that there were 10 hot dogs per pack and 8 buns per pack, and that poor girl just kept putting more and more packs in her cart. But how many would she need to get an equal number of hot dogs and buns? Or maybe a better way to ask that would be, how many packs of hot dogs and how many packs of hot dog buns can she buy to get an equal number of hot dogs and hot dog buns? So, for example, if she buys the hot dogs, there's 10 per pack. If she bought 4 packs, that would be 40. If she bought, there's 8 per pack of the buns. If she bought 5 packs, that would be 40, right? So maybe we can make a chart. Dogs, buns, there's 10 per pack, there's 8 per pack. So if she, and then total of each. If she buys 5 buns, 5 packs of buns, and 4 packs of dogs, she'll get 40 hot dogs and buns. If she buys 8 packs of dogs, she'll get 80 dogs. And if she buys 10 packs of buns, she'll get 80 buns. So you can see there's more than one answer and more than one way to approach this. Another multiple would be a multiple 120, which would be 15 packs of buns, or 12 packs of hot dogs. So today's focusing on least common multiples. And we did sort of a overview before we started this unit on least common multiples and greatest common factors. So the least common multiple is the smallest multiple that would appear in a list. So in other words, it's going to be bigger than each of the numbers. Multiply means bigger. So if we there's two ways to find multiples. One is a list. And if we make a list counting by threes, 3, 6, 9, 12, 15, ends in a 5, so I'm going to stop there because I know if a number is divisible by 5, that it ends in a 0 or a 5. So 5, 10, 15. So now our lowest common multiple is going to be 15. But it didn't necessarily ask for a lowest one, did it? Oh yeah, it did. Least common multiple. So the lowest common multiple of 3 and 5 is 15. There is another method you could use where you take the prime factors. Now this one isn't a good example to demonstrate prime factors because the only factors of 3 are 1 and 3. The only factors of 5 are 1 and 5. So in this case, it's just the product of those two. So let's take a look at this one maybe. The least common multiples, using the list method, we have 4, 8, and that's the list for 4. And my list for 8, I'm just going to stop at 8 because my lowest common multiple of 4 and 8 is 8. But this one does work out better to show you the prime factors. So if I look at the prime factors of 4, that's 2 and 2, or 4 is 2 squared, and then 8 is 2 times 4, which is then 2 times 2. So 8 is 2 cubed. So now to use the prime factorization method, you're going to take each of the bases, but in this example, they only have the base of 2, but they share it. So the least common multiple of 4 and 8 is the base of 2, but then take the highest exponent on that base. So 2 to the third, which is 8. So what is the side length of the smallest square that you can create with rectangular tiles that are 6 by 10? In other words, you want to look at the multiples of 6, and I know all multiples of 10 end in 0, so I'm going to stop at 30, and that's my lowest common multiple. So the side length of the smallest square I can create with rectangular tiles, that measures 6 units by 10 units, is 30 units. So now let's look at prime factorization and the least common multiples. Consider the numbers 11 and 12. What's the least common multiple? Well, 11, I really don't want to write this list out. When you get into bigger numbers, it gets a little more complicated. So the list of 11 would be 11, 22, 33, and the list is going to get long. So the easiest way to do this is to look at the prime factors. 11 is just, it's prime, so it's 11. 11 to the first power. And 12 is 2 times 6, which is 2 times 3. So the prime factors of 12 are 2 squared times 3, which means the lowest common multiple of 11 and 12 is going to be each base. So we have 2, 3, and 11. And then we have to take the highest exponent from each of those bases. So 11 doesn't have a base of 2 as a factor, but those are the things. So we have 4 times 3 times 11, which is 12 times 11, or 4 times 33, which I think is going to be easier for me to multiply this way. That's 12, 132. So now we're looking at rolling 2 dice twice. So this little applet does not have sound, but here we get a 6 and a 7. So our sum was 6 and 7. And the least common multiple of 6 and 7 is going to be, the prime factorization of 6 is 2 times 3, 7 is just 7, so it's going to be 2 times 3 times 7, and then look at the highest exponent. They're each 1, so 6 times 7 is 42. Venn diagrams. The Venn diagram shows the prime factors in prime factorization of 8 and 12. So 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. So 8 is 2 cubed, and 12 is 2 squared times 3. So the lowest common multiple of 8 and 12, we take each of the bases, and then we take the highest exponent from each. And that's just a 1. So 8 times 3 is 24. The greatest common factor. Now, we did do this last week sometime. You can do it with primes as well. Here you only want to take the common bases. So the only common base that 8 and 12 have is 2. And then you want to take the lowest exponent. So here, 2 squared is 4. Remember, factor is division, so it'll be smaller. And multiple is multiplication, so it'll be bigger. So for the factor, you want to take only the base that is common, and then the smallest exponent. For multiple, you want to take all of the bases, and then the biggest exponent from each. So here we have each pack of hot dogs has 10 dogs. Each pack of buns has 8 buns. A shopper wants to buy an equal number of dogs and buns. What's the least number of packs that they can buy? So 10 is 2 times 5. 8 is 2 times 4, and then 2 times 2. So if we rewrite 10 as prime factors, it's 2 to the first times to the 5 to the first, and 8 is 2 cubed. So now, the least common multiple of 8 and 10 is going to be each of the bases, and then the highest exponent from each. So 8 times 5 is 40. That means they'll have 40 buns and 40 dogs. which means there was, what, 10 dogs, so that'll be 4 packs of dogs. And there's 8 buns, so that'll be 5 packs of buns. Lunchroom staff needs to buy an equal number of dogs and buns to feed 60 students. Is it possible to buy packs of dogs and buns to have exactly 60? No, because the common multiples of 8 and 10 are 40, or multiples of 40. 60 is not divisible by 8 or 40. So they could buy 6 packs of buns, because 6 times 10 would give you 60 buns. But they would have to buy, what? If there's, how many? Oh wait, no, I got that wrong. There's 10 per pack of dogs, sorry. So they could buy 6 packs of dogs, but then there's only 8 in the bun packs. So they would have to buy 8 packs, and then they'd have 4 leftover buns, because 8 times 8 is 64. So each pack of hot dogs costs $3.50. Each pack of buns costs $2. The lunchroom staff spends $48. They buy an equal number of dogs and buns. How many packs of dogs and how many packs of buns did they buy? So, let's go with, maybe they bought 40. And this would be 8 times 5. This would be 10 times 4. That's each in 1 pack. So they bought 4 packs of dogs. So 4 times $3.50 plus 5 times $2. That would be $10 plus $14, because $3.50 times 4 gives me 0. 5 times 4 is 20, carry the 2. 4 times 3 is 12, plus that 2 gives me 14. 2 decimal points, so I have to go 2 decimal points. And that is $24. But the problem said that they spent $48, which is double what we calculated here. So they would have purchased 8 packs of hot dogs and 10 packs of buns for a total of $80 each.